Hello everyone, I'm Leonardo Capitani, and it's a pleasure to present our research entitled Functional Response of a Marine Herbivore Fish, Empirical Evidence of Consumer Dependence. After several years of field research, we know that the herbivorous fish per capita consumption rate depends mainly on two ecological factors. On one hand, it's the quantity and the density, the quality and the density of the research, and also its spatial distribution. But also, on the other hand, the consumer abundance and the behavior at individual and population levels are important predictors. So the goal of our research is to answer this question. Does alga density and herbivore density both affect herbivorous fish consumption rate in Western Atlantic tropical reef ecosystems? And we consider in our research the Digenea simplex seaweed and the Acanthurus chirurgo. It's a surgeon fish and it's an herbivorous fish common in the in Western Atlantic oceans. To answer this question, we carry out a field experiment in the Rocas Atoll. The Rocas Atoll is a Brazilian marine reserve where there are no human impact derived from fishing of tourists. Five trials per day were conducted in randomized orders over 4 different days. Each trial was recorded for 15 minutes and with 10 minutes intervals between them, between each trial. And the per capita consumption of seaweed was measured as at a factorial combination of 4 Acanthurus density and 5 seaweed densities. It is important to note that the experiment was done in a closed pool of inside the reef flat, and this pool is disconnected from the other part of the reef flat, so the density of the Acanthurus doesn't change along the low tide period. Here is a video clip from one of the trials, and in slow motion we counted the number of bites each individual gave. And so with this data, we then determined how much algae, how much seaweed was consumed per minute and per individual. For the modeling and statistics part of the research, we use a classical functional response model where the response variable is the instantaneous consumption rate at time t. The units are grams of seaweed consumed per individual per minute. The predictors are the density of algae, the density of seaweed at time t minus 1 at the previous minutes, and the density of the Acanthurus in the tide pool. I pointed out here that the presence of the 3 parameters, the attack rate, handling time, and mutual interference strength. In this form of functional response, the handling time makes the functional response with a hyperbolic shape. Without the handling time, and we fit models that handling time is not present, so we fit a linear model of the functional response. Furthermore, the parameter M, that is the mutual interference strength, defines the type of functional response. So if M is zero, is functional response is a research dependence, while functional response is ratio or consumer dependent if M is equal to 1 or different from 0 and 1. Well, here's the results of fitting the models, and we can see that the hyperbolic consumer-dependent model P2 and the consumer-dependent P1 model, the linear model, provided the best fit accuracies to our data. And if we plot the probability density of the values of the M parameter, we can see that the 95% of the confidence intervals varies among 1 and 2.25. So there's a huge probability that this model is a strong mutual interference strength. Well, if we plot the per capita consumption rate against the seaweed density, here in the y-axis the per capita consumption rate, and the x-axis the algae, the seaweed density, we can see that consumption rate is positive related to seaweed density. And here the box plots represent the observed per capita consumption rate from the trial, the observed, while the solid line is the Bayesian posterior mean model prediction, and the shaded regions are the 50% and 95% posterior credible intervals. So in this plot, we can see that consumption rate is positively related to algae density, but negatively related to fish densities. In the right side here, we can see the same y-axis per capita consumption rate against the fish density. Well, and if we plot the per capita consumption rate against the amount of seaweed available to each individual during the trial, that is the per capita availability of seaweed, we can see that this is the main factor that best explains the herbivorous consumption rate. And this is an important result that we can highlight. We want to highlight here. These results are in agreement with the other findings indicating that the presence of coin-specific can alter the consumption rate in reef fish. Here is an example of two corallivorous species of the genus Chaetodon from Lizard Island in the Great Barrier Reef, and probably the two mechanisms generate the observed pattern. One is the non-random search for research that is heterogeneously distributed in the space, and the other one is the aggression behaviors, the agonistic interaction that are made by fish to avoid competition at the moment of feeding. So, in conclusion, we provide strong evidence that the mutual interfered competition for limiting research influences the herbivorous per capita intake rate in Western Atlantic tropical reef ecosystem. And, and we highlight the importance of coin-specific interaction to model herbivorous fish population dynamics and regulation. Thank you very much, and I'm open to answer any question of you.